Hello, Marcus.
Hello, Elisa.
We're looking back on weeks 4 and 5, track 2 now, and there were interesting questions to our guest expert, Christian Hagelöken, actually on the economics of recycling.
Yes, indeed. So thanks for actually asking me also to give some feedback, because I really find this course very interesting for our industry. And also thanks for those questions that have come in, which we will probably briefly just touch on.
Yeah, I mean, we looked a little bit in the forum, you and I, and we have learned a lot about circularity indicators, and people were talking about it. Which indicators do you think are important to characterize how efficient and circular we use materials, resources?
Answering that question, I know there are numerous kind of indicators out there, and being in the end a process engineer, I tend to always consider it in the thermochemical sense, because that is how we do flow sheeting. And ultimately the thermochemistry, be it in high temperature type process or watery chemistry type processes, or even physical processes, in the end you have to quantify the entropy. In other words, you have to also consider in your indicators deep down the loss of quality of flows of energy, which is all captured by the second law of thermodynamics. Not only in sense of the energy side, but also looking at dilution. Because ultimately, as I always say, if you put a sugar into your cup of coffee, the entropy of the system changes. And to reverse that, to get back the crystal of sugar, you need to put in energy to counter that. And that's ultimately what costs money. And that's really what we are trying to convey in these examples now in these weeks. Obviously also connecting to Christian's thinking, because it comes from Umico, and that's how obviously they make money. They are concentrating stuff into metal form or high quality compounds, which can be used back in products. And that is all ultimately an entropic type discussion. So one needs to understand that in addition to all the other types of indicators, but that is a key one if you really want to bring in the circular and look at the economics bit.
I think it's a really important message, because I think it shows us the physical limits actually of the circular economy as well, right? But going back to what you just said, that it's also a question of money for companies. There was a discussion or a question of a learner who asked, so if we are more resource efficient, and if, for example, if you use products longer, what's in there for companies? So how can this even be economic? What would you say to that?
Oh, well, yes. If you start delving down into the depth of the physics of these large systems, you inevitably will come, quite honestly, to such a solution. And that brings you then closer to design. And I've been involved a bit with Fairphone, considering these, which have also been championing extended life of products and exchangeability of modules. To consider this, which is very important. But then also when you are replacing bits and pieces of your, say, your mobile phone in this case, there must also then be an avenue for that bit that is being replaced. In other words, that then comes back to the design bit. So what do you bring together on a module in a product so that you can easily, but within the constraints of the physics, extract materials again to the highest resource efficiency, to in fact unmix that functionality of materials back into high quality materials that can go possibly in the circular economy paradigm back into that module. That's ultimately what we're trying to achieve. And so yes, it ties very neatly together. And surely the analysis we have done also on exergy, longevity and extended life obviously is important. Therefore, modularity is important. But ultimately, modularity doesn't all mean that you will get all the materials back. You will always lose something. That is physics. That is the laws of thermodynamics that just underline that. But so yes, extended life and lowering the footprint, like Fairphone has shown, is very important.
So then, thank you very much, Marcus. And I think we both look forward to the next week in the course.
I'm looking forward to your answers. I'm looking into your comments and let them come in, because this discussion can be also very illuminating for myself to understand how to best explain this complex topic. And that's ultimately the aim of this MOOC, is to make this stuff accessible to you all. So thanks also Alessa for making this course possible and all the effort that has gone into it to make this discussion possible in the first place. And that's great. Thanks a lot.
Thanks, Marcus. See you soon. Bye.
Cheers. Cheers. Cheers.